A heavy-duty bulldozer is deployed to clear deep snow along a winter road. Using its wide front blade, the machine pushes accumulated snow aside, carving out a passable route for stranded or approaching vehicles. This snow-clearing operation ensures traction, restores mobility, and facilitates further recovery or transport operations in severe winter conditions. The transportation of 73-ton heat exchanger recuperators by LLC-LSEG represents a complex operation requiring precision logistics, specialized equipment, and careful route planning. These large industrial units, critical for thermal energy recovery systems, are characterized by their massive dimensions, fragile internals, and high center of gravity, which demand tailored handling and reinforced transport platforms. Prior to loading, engineers performed structural assessments and prepared lifting points on the recuperators to ensure safe engagement with hydraulic cranes. Route selection was based on axle load constraints, bridge clearances, and turning radii, with several road sections temporarily reinforced or cleared of overhead obstructions. Throughout the journey, escort vehicles and traffic coordinators accompanied the convoy to manage traffic and ensure safety, especially during night moves or when navigating sharp turns. Real-time monitoring of load stability, tire pressure, and mechanical integrity was conducted via onboard telematics. The Ural truck, transporting timber from the forest, drove up the rough and steep road. Despite the roaring engine and constant effort, the truck struggled to climb the hill. The driver waited until the truck stopped, and finally, waited for a tractor to come and help pull the truck up the hill. Logs are transported from the forest using heavy-duty trucks designed for rough terrains. After being collected at a central point, the trucks begin their journey along narrow, snow-covered roads typical of the taiga. Drivers carefully maneuver through dense forests, icy paths, and steep slopes, often in extreme weather conditions. The trucks maintain slow and steady speeds to ensure stability, especially when navigating sharp turns or climbing inclines. Tire chains are used to increase traction on slippery surfaces. During long trips, the drivers remain alert to avoid obstacles such as fallen branches or deep snowdrifts. Despite the harsh environment, the transportation process is continuous, ensuring that timber reaches its destination efficiently. This phase plays a crucial role in the overall logging operation within the taiga forest. The rescue begins by positioning a powerful tow truck in front of the Kamaz, loaded with logs. Heavy-duty chains are securely attached between both vehicles. The tow truck gradually applied force, pulling the stuck truck forward. The Kamaz wheels spin on the icy surface, but steady pulling helps it regain traction. After several attempts, the truck slowly moves out of the snow and onto firmer ground. Finally, the loaded Kamaz is freed and able to continue its journey. Prinoth developed an innovative transport solution for the Norwegian Troll Station in Antarctica, aimed at increasing efficiency and reducing environmental impact. This specialized vehicle was designed to handle large loads with fewer personnel while minimizing fuel consumption and transport time. Key features included excellent traction, optimized weight distribution, and a trailer equipped with a self-loading crane, enabling operation across various icy terrains. The project demonstrated Prinot's capability to deliver high-performance, specialized off-road vehicles for extreme environments. The MAN 8x8 all-wheel drive truck becomes stuck during an off-road operation. Despite its powerful drivetrain and terrain capabilities, challenging conditions such as deep mud can immobilize it. Eventually, it is successfully recovered by another heavy-duty vehicle using a tow cable. In May, the Pachorneft Zimnik winter road was actively used for transporting equipment and supplies across the challenging Arctic terrain. This temporary road facilitates access to remote oil fields during colder months when the ground is frozen solid. Heavy trucks and specialized vehicles navigate carefully over the snow road and tundra, ensuring continuous supply chains for drilling operations. Maintenance teams regularly monitor the road's condition to guarantee safety and prevent disruptions. The Zimnik plays a crucial role in supporting Pachorneft's extraction activities, allowing efficient logistics despite the harsh environmental conditions of the region. In the challenging conditions of the Pachorneft winter road season, a typical scenario unfolded that demonstrated the complexity and coordination required to maintain transportation reliability in Arctic terrain. During a routine heavy transport convoy along the temporary ice and snow-covered Zimnik, one of the multi-axle freight trucks became immobilized. The cause was a deceptive soft spot beneath the snow crust, where partial thawing had undermined the load-bearing capacity of the frozen track, resulting in the truck's rear axles sinking into the snowpack. To initiate recovery, a bulldozer was promptly deployed. Its first task was to remove the compacted snow and ice surrounding the stuck vehicle. The dozer operator began by cutting lateral relief paths and carving out accumulated snow from the truck's approach and retreat trajectory. This created enough clearance for maneuvering and allowed direct access for recovery vehicles. During this phase, attention was paid to maintaining stability and avoiding further displacement of the truck under its load. Following snow clearance, a second heavy-duty support truck, fitted with an industrial-grade tow bar and reinforced winch system, was brought in. Recovery personnel attached heavy synthetic tow straps and steel shackles to the chassis recovery points of the immobilized vehicle. With clear radio communication between drivers and ground crew, the pulling operation commenced. The towing vehicle began with gradual tensioning to prevent damage to either truck, and once traction was secured, steadily pulled the stuck vehicle out of the soft zone. This recovery operation demonstrated standard Arctic field procedure, use of dedicated snow-clearing machinery, proper rigging techniques, and experienced coordination to minimize delays and mechanical stress. Once the stranded truck was safely returned to the stable track, final inspections were carried out on its drivetrain, suspension, and tire systems before the convoy resumed movement. Such recovery events are part of regular operations along the Zimnik, especially during shoulder season periods when weather instability can rapidly change ground conditions. They highlight the importance of having both skilled personnel and specialized equipment on standby to ensure safety and continuity of supply in remote oilfield regions like those operated by Petronet. The startup of the T-130 Bulldozer marks a critical phase in its operational readiness. Before ignition, thorough inspections are conducted, including checking fluid levels, hydraulic systems, and engine components to ensure everything is in optimal condition. The operator follows a standardized startup procedure, which begins with activating the electrical system and engaging the starter motor. A person sitting in front turns on the ignition and watches the vehicle operate. Once the engine is running smoothly, systems such as transmission, cooling, and hydraulics are tested for proper function. The T-130 is equipped with advanced control panels that provide real-time diagnostics to monitor engine performance and detect any anomalies early. After startup, a series of operational tests are performed to confirm the bulldozer's responsiveness, blade movement, and track functions. This systematic approach guarantees safe and efficient machine operation, minimizing downtime and ensuring readiness for heavy-duty tasks in construction or mining environments. The Bison X camp buildup, held at Italy's Stelvio Pass Glacier, showcased a world-class slopestyle course crafted by FTech Snowparks in collaboration with Bison snow groomers. From September 21st to October 18th, 4 7-day sessions offered freestyle athletes optimal preseason training. The Bison X groomer shaped innovative rail sections and jumps, ensuring perfect transitions for skill progression. With South Tyrolean expertise, the camp attracted elite riders, including Olympic teams, to a spectacular setup at over 3,200 meters, preparing them for the competitive season. Specialized Bison snow groomers and utility vehicles were used to transport heavy equipment, construct structures, and prepare the camp area in extreme winter conditions. A heavy John Deere 6,920 truck becomes buried in deep snow, unable to move under its own power. A powerful tow vehicle is dispatched to assist. A strong towing cable is securely fastened to the front of the stranded truck, while the opposite end is attached to the rear of the rescue vehicle. Once connected, the tow rig gradually applies tension and begins pulling. Step by step, the tow vehicle gains traction, extracting the John Deere 6,920 from the dense snowpack. The rescue vehicle's steady pull overcomes the resistance of the snow as the stuck truck slowly surfaces. Finally, the truck is freed and rolled back onto solid ground, a successful recovery thanks to careful cable attachment and controlled towing force. The IMT 549-4WD tractor demonstrates its impressive off-road capabilities as it moves steadily through a thick layer of snow. Equipped with 4-wheel drive and robust tires, the tractor maintains excellent traction and stability even in challenging winter conditions. Its powerful engine ensures consistent forward motion without getting bogged down. Despite the slippery terrain, the IMT 549 shows reliable handling and resilience. This performance highlights its suitability for demanding agricultural and forestry tasks in snowy or rugged environments, making it a dependable machine during harsh winter months. Rescuing a frozen tractor from a glacial river, a challenging operation in extreme conditions. Deep in a remote frozen wilderness, a challenging and dangerous rescue operation took place to recover a tractor that had become trapped in a glacial river. The tractor, which had been abandoned and left to freeze in the harsh Arctic environment, was found submerged almost entirely under thick layers of ice and frigid water. Only a portion of its roof and exhaust pipe remained visible above the frozen surface. The discovery of the machine triggered a complex multi-step rescue mission that involved manual labor, strategic planning, and the use of heavy-duty equipment to recover the vehicle from nature's icy grip. The process began with locating the exact position of the submerged tractor. As the team arrived at the site, they saw that the vehicle had been completely encased in ice, with most of its body submerged beneath the surface of a frozen glacial river. The surrounding landscape was a treacherous mix of snow, ice, and slush, making movement and operation difficult. Despite the extremely low temperatures and challenging conditions, the rescue crew was determined to retrieve the machine. To begin the recovery, workers first used shovels and ice picks to manually break and clear the thick layers of ice surrounding the tractor. This was a slow and physically demanding task, requiring considerable strength and caution. The rescuers had to carefully chip away at the ice without damaging the vehicle beneath. Little by little, they revealed more of the submerged tractor, uncovering the front, sides, and rear. As the ice melted and cracked away, the extent of the submersion became clear. The tractor was stuck deep in the icy water, resting at a tilted angle and partially embedded in the riverbed below. Once the full body of the tractor was visible and accessible, the next phase of the operation focused on planning and preparing the extraction. Due to the unstable and slippery environment, pulling the tractor out directly would have posed a significant risk. Therefore, the rescuers devised a clever solution using large wooden logs. They drove these logs into the icy water at an angle, forming a ramp or guiding surface that would help slide the tractor out of the riverbed and up to safer ground. The logs, positioned closely together, created a sloped surface to provide traction and reduce resistance during the pull. With the wooden ramp in place, the team began attaching heavy-duty tow cables to the tractor. The cables were securely fastened to the front section of the tractor, wrapping tightly around its metal frame. The opposite ends of the cables were initially tied to a sturdy wooden stake or post nearby. This setup provided temporary tension and allowed the team to assess the force required to move the tractor before involving any external pulling vehicle. While waiting for a rescue truck to arrive, the team continued to monitor the ice conditions and reinforced the cable connections to ensure stability. Once the rescue truck reached the site, a large, powerful vehicle capable of towing several tons, the crew transferred the cable ends from the wooden post and attached them firmly to the truck's towing system. The next and most critical stage of the operation began as the truck started to reverse slowly, exerting a controlled and gradual pulling force on the tractor. The towing was done in small increments, allowing the ice and frozen ground to adjust without sudden shocks that could damage the equipment or break the cables. The wooden logs underneath played a crucial role during this phase by reducing friction and guiding the tractor along the correct path. As the cable tightened and the truck continued its steady pull, the tractor began to shift and rise from the water. After several minutes of slow movement and mechanical effort, the tractor's wheels finally broke free from the icy riverbed. Slush, water, and broken ice splashed out as the heavy vehicle emerged, inch by inch from the frozen water. The engine, frame, and cabin were all soaked and encrusted with frost, but miraculously, the body of the tractor remained largely intact. The truck continued pulling until the entire tractor had been dragged completely out of the river and onto solid ground. This marked the successful completion of the main recovery operation. However, the work was not over yet. The team immediately began inspecting the vehicle for structural integrity and damage. Meanwhile, any remaining water and ice within the machine needed to be drained to prevent further damage due to freezing. The entire process, from manual ice removal to the final towing, required immense physical effort, coordination, and patience. The rescuers worked in freezing conditions, often surrounded by icy water, sharp ice shards, and unstable ground. Their resourcefulness using wooden logs as ramps and anchoring systems, and their reliance on both manual tools and modern machinery demonstrated a perfect blend of traditional methods and advanced engineering. This operation was not only a testament to the resilience and determination of the rescue team, but also an illustration of how humans can work with nature's elements, even in the most extreme conditions, to recover valuable equipment and restore operations. The successful extraction of the frozen tractor serves as a reminder of the challenges faced by people who work in remote, icy environments and the ingenuity required to overcome them. Following the recovery, the tractor was transported to a safe location where further repairs and inspections could be carried out. Although it had spent a significant amount of time submerged in glacial water and ice, the possibility of restoring it to working condition remained strong due to the prompt and careful recovery. This event also highlighted the importance of quick action when dealing with freezing environments where machines can quickly become immobilized or severely damaged. In conclusion, the rescue of the tractor from a glacial river was a highly demanding operation that involved a series of strategic and technical steps. From manually breaking ice, setting up wooden ramps, tying cable systems, and employing a heavy-duty rescue truck, every stage was carefully planned and executed. The entire team displayed exceptional endurance and collaboration in the face of nature's unforgiving cold. Their efforts not only saved the vehicle but also demonstrated what is possible when human determination and intelligent planning are combined to solve even the most daunting challenges. A Massey Ferguson MF 175 tractor loaded with timber struggles to cross a muddy, snow-covered forest road. The terrain is extremely challenging, with thick layers of wet snow and deep mud making the surface dangerously slippery and soft. As the tractor slowly advances, its wheels begin to sink and lose traction, threatening to trap the vehicle completely in the slushy terrain. Recognizing the difficulty, several men rush to assist. They climb onto the front of the tractor, using their body weight to increase traction on the front wheels and reduce the risk of the rear tires spinning in place. Their presence not only stabilizes the machine, but also shifts the balance forward, enabling better grip. They push and pull, encouraging the tractor forward step by step. Despite the heavy load of logs, the determined teamwork and careful maneuvering allow the tractor to crawl through the most difficult patches. The engine roars under strain, mud splashes from the tires, and the tractor inches ahead. This scene captures both the raw challenge of rural logging operations in winter conditions and the power of human effort in overcoming nature's obstacles. Through coordination and persistence, the tractor finally escapes the muddy trap and continues its journey through the forest. A large truck was stuck on a snowy road, its wheels stuck deep in a thick layer of snow and ice. The thick layer of frozen snow around the wheels made it impossible for the truck to move. Faced with this situation, several drivers came together to carry out a challenging rescue operation in harsh winter conditions. The first step was to use shovels and chisels to carefully dig out the frozen snow surrounding the truck's tires. They worked methodically, trying to expose as much of the tire surface as possible without damaging the vehicle. Despite their efforts, the thick layer of frozen snow in front of the wheels proved difficult to remove. To solve the problem, one person brought a chainsaw and began cutting away the hard ice in front of the truck. This step was crucial to clear the wheels. Once a significant portion of the ice had been cleared, the team continued digging with shovels and chisels, focusing on clearing each patch of frozen snow and ice around the tires. The teamwork and perseverance shown was amazing. Despite the freezing temperatures and physical exhaustion, the rescuers continued their work with great determination. After much effort and much digging and trimming, they finally cleared enough space for the truck to move. The road ahead was clear, and the wheels were free of snow. The driver was able to start the engine, and the wheels could move. The rescue mission was a great success, thanks to the coordination, the support tools, and the tireless efforts of the people. In harsh winter environments, clearing large snowdrifts is essential to maintain access to roads and facilities. A powerful K701 tractor in action, confronting and removing a massive accumulation of snow. The K701, manufactured by the Kirov plant in Russia, is a heavy-duty articulated tractor designed for agricultural and industrial purposes. Thanks to its robust design, immense power, and adaptability, it has become a valuable machine for snow removal in severe climates. The K701 slowly advancing toward a towering snowdrift. This snowbank, formed by days of snowfall and wind, blocks a rural road or access route. Its compacted structure makes it difficult to remove with standard snowplows. However, the K701 is equipped with a large front-mounted blade that cuts into the snow with brute force. The tractor's articulated steering and four-wheel drive allow it to maintain traction and push forward steadily, even over icy surfaces. The operator skillfully positions the blade and lowers it to engage the snow at its base. The tractor pushes through in a straight line, displacing enormous chunks of snow to the sides. In particularly dense areas, the K701 must make multiple passes. The driver reverses and then moves forward again, gradually reducing the snowbank's height and width with each attempt. The engine roars as it powers through the resistance, demonstrating the machine's raw strength. Thanks to its wide stance, heavy frame, and high horsepower, the K701 can remove significant volumes of snow in one sweep. The operator occasionally tilts the blade to one side, directing the snow away from the path and creating clean embankments. The articulated chassis allows the tractor to turn tightly, which is essential for repositioning and navigating around obstacles. The operator remains protected in the elevated enclosed cabin, which offers good visibility and shields against wind and freezing temperatures. Inside, the controls allow fine-tuned manipulation of the blade's height and angle, giving the operator precise control over each movement. As the clearing progresses, the once blocked road becomes visible. The snow is pushed to both sides, forming neat banks along the shoulders. In areas where the snow is especially packed or icy, the tractor compresses and breaks it apart before pushing it. This approach prevents damage to the blade and ensures smoother movement. The process is repeated until the path is fully cleared and safe for passage. What might take smaller vehicles hours or even days is completed far more efficiently by the K701. The operation highlights both the power of the K701 and the skill of the operator, who must judge angles, snow density, and steering accurately. In conclusion, the K701 tractor remains a reliable and effective tool for extreme snow removal. Its engineering, power, and operator skill combine to tackle even the most formidable winter obstacles. Its strong engine, robust design, and adaptability make it a valuable asset in maintaining road accessibility during snowstorms or after prolonged snowfall.
Всем салам алейкум. Посмотрел до конца. Спасибо.